So the idea is we want to solve the system of the equation. Okay, the system is x prime equal to the a times x plus the extra function. Okay, that's it. If you want to do it with the variation of parameter, first thing to do, you have to solve this equation. Okay, so we solve the homogeneous one. Okay, and we get the solution. Solution is going to be yc, which is going to be c1 y1 plus c2, okay, c2 x1 and the c2 c1 x1 c2 x2. Okay, then we have to find the xp. So the particular solution is the missing one. If you find it, then the general solution is going to be x equal to the xc plus xp. So the method that we created it was just method of variation of the parameter. We change this solution into the matrix form. The matrix form that we suggested was this one. Okay, we introduce a function. Okay, we call this one phi of. Okay, that was phi of t. Okay, we change this one to the phi of t times c, and then oops. So okay, so we rewrite this one as the phi of the t times c. Okay, that is the one. Then what we did, we replace the c by u. So we replace the c by u. So the x of p is going to be y of t times u. Okay, that's going to be one, and we have to find the u. So this y of t would be a matrix. Okay. This matrix is defined by, we define this one by x1, x2, y1, y2. You see, when you find these two solutions, solution is going to be, the first particular solution would have x and y. So it's going to be x1, y1. And the second solution would have a vector solution, and that would be x2, y2. We're going to bring them here, and we look for u. So u would be a vector like u1 and u2 that we have to find it. Okay, and we proved the other day that how I'm going to find it. So the conclusion was that yp is the one that I proved. At the end, we proved that the x of p is going to be y of t times the integral of y inverse of t times f of t d of t. So that's the form of the solution that you are going to have. You have to form this one. So you have to solve the homogeneous one first. You solve homogeneous one. As soon as you find the x1, that would give you the first column, x1, y1. You find the x2, that give you the second column, x2, y2. That's going to be the matrix phi t. So what you do, you have to find the inverse of the phi of t. So first thing to do, you know that the inverse of the phi of t, you find the determinant, and we talk about how we're going to find the inverse of a 2 by 2 matrix. Then you multiply by f of t over here, and you integrate it. When you integrate it at the end, you are going to come back and multiply by phi t again. It's a little bit takes time, but this is it. This is the way we're going to do it. Okay, so you must know these preliminaries to be able to find that. You must know how I'm going to form phi of t, especially, okay, the form of the matrix that we're going to have, and then the rest of this is going to be just straightforward. So let's practice. We give you one of them on the file. So example, the example is going to be, particularly is going to be the one involving sine function, exponential function, this type. We want to solve the system, okay? Solve the system. Sometimes you give it the instruction, but these type of systems are clearly should be done by the variation of the problem. So the system that I'm going to be interested in is going to be x prime equal to the matrix is -2, 1, okay, 1, -2. That's a matrix times x, and that extra part is going to be 2e to the negative t, okay, and the 3t. This is the one. See, if you want to do with this one with a undetermined coefficient, it takes quite a while to be able to do it. So try that method when you have a linear polynomial, the degree 1, at most 2. There is 1 in your book to get this one. Okay, so the method is going to be variation of the problem. Exactly what I suggested over here. You have to solve the homogeneous one first. You get the solution would form phi of t. You see x1, y1, the first matrix. This is the first solution. This is the second solution. So you find your phi of t, and then you work on the inverse of the phi of t, and then you just integrating and just keep going to get the final answer. Okay. So this would be the case. I just want to make sure I gave you all the formulas here. That's it. This is so the end is here. You don't have to do the phi of t times u because I already proved it for you. So don't be surprised that you're not going to see the u. The other way to do it is in your book. You just put everything together, but try to avoid the matrix notation so that give you two systems of the equations to solve it. But if you think about that two system of the equation, the system of two unknown okay, and you know that you can quickly write it down as in a matrix form. But this is much better. You can have a look at that if you like it. But this is much better, and it can be extended, of course. This is a system of two equations. You can have an equation. So this one, okay, there you are. It's straightforward, just patiently go through it. So the first thing to do, you have to solve the homogeneous one, okay? So first thing to do, you have to do the x prime equal to -2, 1, 1, -2 times x. And you know how to solve this one. You have to go for the, eigenvalues of a matrix. We are familiar with those notations, so we go for it right away. We are going to find what's going to be the determinant of a minus lambda I, which is going to be equal to the determinant of, this is going to be -2 minus lambda, 1. And this is 1, -2 minus lambda. That's the determinant of this matrix. Plus multiply to find it. So that give a -2 times. So they are going to be the same. So we can square it or just write it down in a square form. It's going to be -1. Okay, FOIL, or this is -2 minus lambda squared. So this is going to be a square of the first one. It's going to be 4. 2 times first times second would be plus, plus 4 lambda and plus lambda squared. Okay, lambda squared minus -1. So combine the like terms and write it down in quadratic form. It's going to be lambda squared plus 4 lambda plus 3. Really equal to the 0, and easy equation to solve. Okay, so we have real solution because it's going to be lambda plus, lambda plus 3 times lambda plus 1 equal to the 0. So we are going to have two solutions. Okay, so I take the first solution to be lambda 1, which is a -3, and I take the second solution to be lambda 2 to be equal to the -1. So this is going to be the solution so far. Okay, any question? Continue finding eigenvalues, eigenvectors. Okay, put them together. Usual practice. So we are going to start with the lambda 1 equal to the -3, and we go for the vector. So we are going to form a minus lambda I times k equal to the 0. Okay, and this is it. So go back. You know that you substitute here. Lambda equal to the -3 here. So that give you a -2, okay, -2, -3. And that's going to be 1, 1, -2 minus -3. This is going to be the matrix part. Okay, then you multiply by k, we may call it k1, k2, then equal to the 0 or 0, 0. Simplify this one is going to be -2 plus 3, which is 1. So that give you 1, 1, and this is going to be 1, 1. Okay, everything's going to be the same. So times it by k1, k2 equal to the 0, 0. Just pick one of them because the system is dependent. So you are going to have a lambda 1 plus lambda 2 equal to the 0. Just pick, lambda 1, sorry, k1 equal to negative k2. So pick the k, okay, you can pick any number you like. So I'm going to put it here. So I pick the k2 equal to the 1 and the k1 equal to the negative 1. So the first k is going to be, if you want to call it k1, just k would be fine. So it is going to be negative 1 and 1. Okay, negative 1 and 1, and that will give us our first solution. Okay, so the first solution is going to be x1. Okay, x1 is going to be negative 1, 1, negative 1, 1 times e to the negative lambda. Okay, I multiply it together because I need that x1 and x2 for the matrix of the phi of t that I'm going to form. Okay, are you done? I'm going to go to the next page. Yes.
You said e to the negative lambda.
E to the
So it's already -3. So should it be +3? Or
no. It's e to the lambda t.
oh, okay.
Sorry, e to the negative 3t. Negative 3t. Okay, I'll go to the next page and correct that. Use it because I have to multiply to get those two. You see, I need this one. You see, this is going to be this column, x1, y1. You get it here, okay? So this is it. So I'm going to make it here. So that's it. So we got the x1. I repeat it again. That we picked negative 1 on the top. So it's going to be, if you multiply it, that give a negative e to the negative 3t. Okay, and e to the 3t. Okay, this is going to be the one. And this is, in fact, is going to be that x1 and y1 that you are going to use for that formula. Okay, so you call it x1 and y1, and then you are going to use it when you want to form the matrix phi of t. Okay, that's going to be x1. So we repeat it again to get the x2. The second solution coming when the lambda was equal to -1. So we go and form that a minus lambda I times k equal to the 0 again. You go back and substitute the lambda equal to the -1 in that matrix, so that give a -2. It's going to be -2 plus 1. Okay, -2 plus 1, 1. And that is 1, and we have a -2 plus 1. Okay, times k1, k2 equal to the 0, 0. So, the top would give you, a -1, 1, yeah, and 1 and -1. So this is going to be the other format that we are going to have. Just let me check this. Okay, times the k1, k2, 0, 0. So in this case, you get negative k1 plus k2 equal to the 0. So the k1 and the k2 are equal to each other. Okay, so the second k, that, so it's going to be equal to 1. So the second one is going to be 1, 1. Okay, that's going to be 1, 1. And we are going to get the second solution, which is going to be x2. Okay, and the x2 is going to be 1, 1 e to the, okay, e to the negative t. Lambda t, which is going to be -2. Okay, so that's going to be your x2. And if you just take it inside, so this is going to be e to the -t, okay, and e to the t. This is your second solution, okay, and this is the one that we are going to call it x2, y2. You know that each component will give it the solution of the original. Yes,
That's the bottom one still e -t.
e to the negative. Okay, so that's going to be right. Okay, so we have the solution, and we have, these are going to be the column of that matrix phi of t that we suggest in order to get the solution. Okay, so far you have the you have the homogeneous solution, okay? So this is going to be, you make a record. So XC is going to be what? It's going to be C1 X1 plus C2 X2, okay? You know, if you like, you can repeat it, but otherwise you leave it and you accept it. So, and we already got the solution, okay? So it's going to be C1 negative e to the negative 3t, e to the 3t, you don't have to, plus C2 e to the negative t, e to the negative 2. So this is going to be your YC. Question.
Why is it not e to the negative 3t?
Because I made a mistake. That's it. It's a negative 30. Yeah, that's why. That's my mistake. Okay, so we get the homogeneous one. Are you ready? Now we have to find the XP. That's one. Since we proved everything, so we go with the formula, right? Okay. Otherwise, if you want to go through it, like the variation of the parameter, it's going to be your job. Okay, XP. So we know the formula for the XP. We proved it, so we're going to use it. XP is going to be phi of t integral of phi inverse of t f of t d of t. Okay, that is going to be the case. And where or when phi of t, it's going to be this matrix. Okay, it's going to be x1 y1 x2 y2. Now you substitute now. So x1 y1 is the solution referred to the solution referred to the x1, which was a negative, you see how here, negative e to the negative 3t, and this is going to be e to the negative 3t. And the second column is e to the negative t, e to the negative t. This is your matrix. This from now on, this is your job. It's all algebra. So what we have to do is we have to find the inverse of this matrix first. Okay, by inverse of the t. We already given you the formula, so you have to find the determinant first. Okay, then use that shortcut that we talked about earlier. So the operation is so finding. Okay, so the next step is find inverse of t. Okay, that's one. Okay, I gave you the formula. So we have to find the determinant of this matrix first. So work on the determinant carefully. So what's going to be the determinant of QT? Cross multiply these, okay, to get the unit true. I write it down. So remind you, is a negative 3 to the negative t times e to the negative t minus the other one, e to the negative 3t times e to the negative t. Okay, carefully multiply to add the power. It's going to be negative e to the negative 4t, the first one. And the second one would be negative e to the negative 4t, the second one. Okay, you combine it together, so that will be negative 2e to the negative 4t. So that would be the determinant of the, okay. So that's going to be the determinant of the QT. It's going to be negative 2e to the negative 4t. Okay, now we are ready to get the inverse of this matrix. Remember, for the inverse, this is the matrix that you have. The way we're going to do it, remember, we switch the terms on this diagonal, and then we change the sign of the other two. That's the formula that we give. And divided by the, okay, divided by the term. I write the formula again for you to remind you. Any question? Are you ready?
Is it possible for the this determinant to be equal to 0?
No, if it's going to be 0, you won't get any solution. It's fine, because you have to divide it. Because your matrix is not going to be invertible, in that case, you can do it. Okay, so let's continue getting the inverse of this one. Okay, I just remind you, the other day we talked about it. Just to remind you, if A is A, B, C, D. Okay, so the A inverse is going to be 1 over determinant of A. Then the matrix, to switch these two. So you switch the D and the A, and opposite side for the B and the C. So you must know this formula. Okay, switch the term on the diagonal, and then change the sign of the other two. So we are applied to the phi inverse of t. Okay, phi inverse of t equal to 1 over. The determinant of the matrix was a -2. Okay, -2e to the negative 4t. Okay, -4t times the matrix. So you have the matrix of the phi, switch the term on the diagonal. So if you switch the term on the diagonal, that give you e to the -t. I have it here. You double check with the one they have. Negative e to the -t. This is going to be negative e to the -3t. And the other one should be negative e to the -3t. Okay, that's why. Because the term on the diagonal start with the negative, that was negative e to the -3t. Okay, the other one we switch it to the e to -t, and then for the other one, we just switch the signs. Okay, so this is going to be the case. You better take this determinant inside, because then you want to multiply this one by f of t. Okay, so you take it inside, you divide all the terms by -2e to the -4t to simplify it. So this is going to be phi inverse of t equal to, so this is the case. You can divide it and simplify. I write it down for you, but you can do it right away yourself. It's going to be e to the -t over -2e to the -4t. Okay, and this is going to be -e to the -t, and that's a -2e to the -4t. Okay, and this is going to be negative, and that's a -e to the -3t divided by -2e to the -4t, and this last one would be -e to the -3t. Okay, -3t and -2e to the -4t. And bring the e to the -4t up and simplify all of them. Okay, so phi inverse of t is going to be, three I write it down. Okay, so I pull out the -½ here. It's going to be -1/2. You see e to the -t, e to the -4t. You remove this one up, it's going to be -t plus 4t. -t plus 4t would be e to the +3t. Okay, you divide with the common base, you subtract the exponent, that's it. So for the second one, it's going to be -½ Move this one up, it's going to be -t plus 4t. Okay, that gives you e to the 3t again. Okay, and for the bottom, the same thing, it's going to be -½
The top one's positive, top right.
The positive, yes, you are right, positive. So that give you what? That give you e to the t. And this would be also positive, and that would give us e to the t. Okay, nicely done. Any question? Yes.
The top right, the 1/2 e and the 3t should be positive too.
This one, yes, you are right. Thank you. Okay, positive, negative, positive. Okay, you have only one -3, other not. Okay, so that's going to be phi inverse of t. Any question? Now you have to multiply by f of t and then integrate it. Okay, so you get the phi inverse of t times f of t. So this is going to be, we have the matrix. This is the matrix -½ e to the 3t. Okay, 1/2 e to the +3t. And that gives 1/2 e to the t, 1/2 e to the t times f of t. What was f of t? Remember that it was 2e to the -t, 2e to the -t, and the 3t. So this is f of t. Okay, multiply them together. Multiply it. This is going to be the result. So the result is going to be, this is it, the matrix. Okay, dot product of these. Multiply these two together. Negative 1/2 and the 2 would cancel out, so that give you negative. Okay. So that give you, see this one? I'm going to write down right away. Negative 1/2 the 2, that give you negative e to the. You have 3t e to the negative t, that give you negative e to the negative 2t. Okay, I'll multiply these two together. Then dot product, these two together, it's going to be plus 3/2. 3/2 e to the 3/2 t e to the 3t. Okay, so it's going to be negative e to the negative 2t plus 3/2. Okay, plus 3/2 t e to the 3t. Do the second one. If you multiply the second one, that give you, everything will be cancelled out. 1/2, that give you 2 e to the t e to the negative t. If you simplify, you get 1. Okay, if you multiply these two together, that give you plus 1/2 t e to the t. That's it. So that give you phi inverse of f of t. Yes,
Wouldn't it be 1 plus 3/2 t?
1 plus,
Why? Because I passed
okay,
it.
yes, you got it. 1 plus 3/2. Okay, everything all right? So this is it. What next? You have to integrate it. Integrate it, then you multiply by phi of t, that give you the x of t. Okay, so what is going to be the integral of phi inverse of t, f of t, d of t? You know that if you want to integrate matrix, you have to go inside and integrate each entries, if you like. And so you are going to have the integral of, okay, integral of negative e to the 2t plus 3/2 of t e to the 3t. That's the first one. And the second was going to be integral of 1 plus 3/2 of t e to the tt, so dt, and the bottom one dt. Okay, that's it. So we have quite a lot of integral to find by that famous method that they have. But you know, it can be done. So I just do it one by one. I list it here. For the first one, I have e to the negative 2t dt. That's easy. Okay, this is going to be negative 1/2 e to the 2t. That's the first one. It's exponential function, never change. You need your prime, you divide it. So that's going to be this first. Then for the other one, we have to use that famous table that we have. So it's going to be 3/2 t e to the 3t dt. So it's going to be 3/2 of integral of t e to the 3t dt. Okay, a short tabular method will give you the result right away. There. So this is going to be positive. We put the t, and we have the e to the 3t. And this would be negative. You differentiate, you integrate 1/3 of e to the 3t. One more step, this would be 0. You integrate again, that you 1/9 e to the 3t. So you collect the information. This is it. Okay, so what's going to be this integral? This is going to be equal to the 3/2 times it by 1/3. Okay, 1/3 of t. 1/3 of t e to the 3t. Okay, minus 1/9. 1/9 of e to the 3t. And if you multiply the 3 and 3 would cancel out, that give you 1/2 of the t e to the 3t. And this one would be negative 1/6 e to the 3t. Okay, so then, then we add them together. So that would complete the first row. We come back, we go back and substitute. And we have one more to do for the second one. And then we're done. Okay, any question? So I'm going to go to the next part. And I just do it. The other one is easy. T and ET. Let's do it. Yes, question.
I'm just still writing.
Okay. So the other one is TE to the TT, which is easy. TE to the TT minus E to the T.
Thank you.
Okay, done?
Yep.
So the second one is straightforward. So I just give you the solution for that one right away. So the other part is going to be, okay, so the other part is 1 plus 3 half. 1 plus 3 half of TE to the T dt. That's easy because it's going to be T plus 3 half. And that is method TE to the T minus E to the T. Okay, but that's popular method. Nice to give you this one. Okay. And so the final answer for this is going to be T plus 3 half of TE to the T minus E to the T. Okay, so we put them together and we declare the, okay, so basically this is going to be integral of y inverse of t, f of t, d of t. So if you put them together, this is the final answer. Those integration that we did. I write it down, we can check it. It's a negative half, okay, negative half e to the 2t plus, okay, negative 1/2 e to the 2t plus 1/2 of t e to the 3t minus 1/6. So minus 1/6 of e to the 3t. It's the first row, and the second row is going to be, the second row we have it here. So it's going to be t. Okay, we have the t plus 3/2 of t e to the t. Okay, 3e to the t. And I missed the 3/2 here. So when you want them together, that give also 3/2. Okay, t plus 3/2 t e to the t minus 3/2 of e to the t again. So this is going to be your matrix over here. Any question? One more step. You have to multiply by 5t.
Where did that whole row on the top come from?
Integral of a second part.
Okay.
You see that was a 2-row.
Okay.
First row, second row was easy. I did it right away. Okay, any question? But you know that you have to multiply by phi of t to get x of p. So x of p, see x of p was phi of t. I just repeated. Integral of phi inverse of t, f of t, d of t. So you bring your phi of t, and this is the phi of t was a negative e to the negative 3t. Okay, e to the negative t, and then e to the negative 3t, e to the negative t again. So that was, I think, that was the phi of t. Now you have to multiply by these three new metrics over here and simplify it. So you have to multiply it in 1/2 of e to the 2t. We have to repeat it. 1/2 of t e to the 3t minus 1/6 of e to the 3t. The bottom one would be t plus 3/2 t e to the t minus 3/2 of e to the t. So as a matrix, if you multiply together, you multiply the first row by e to the negative 3t, and you multiply the second one by e to the negative 2. Everything would be canceled out. Yes, that's good.
For this one where if the lambda is repeated, then do you do the same process next?
The process, yeah, because the procedure, yeah, because you need to do two solutions.
Yeah.
Yeah. The first part is the same as usual.
Okay.
Because the second part that you want to find xp, okay, the xp depends on the x1 and the x2.
Yeah.
So you already got the x1 and x2. Even it's going to be complex. That takes a little bit time. But yeah, it can be done. Okay, so you multiply the first one by e to the negative 3t plus the second one by e to the negative t. Lots of these e to the t, all of them cancel out. And this is what you are going to get. Okay, I multiply it, I write it down right away. So if you multiply these two together, you see that give you a positive half. Positive half e to the negative 3, e to the 2, that's give you e to the negative t. Then I continue getting the second one. The second one give me negative 1/2. 1/2 t, e to the negative 3t, e to the positive t will cancel out. Then I multiply this one, that give me a plus. Okay, it's going to be plus 1/6. Again, 3t and 3 would cancel out. So this is going to be what I got when I multiply this one by the first row. You continue plus, you multiply this one by the second row. So it's going to be t e to the negative t. If you multiply e to the negative t over here, you will lose it. So that give you plus 3/2. Okay, plus 3/2 t. And then you multiply by this one, you lose it. So that give you negative 3/2. So that would be the first row. Any question? It's like a dot product. So we do the same one again for the second one. Everything is the same, but there is a change in signs. So opposite side. So it's going to be negative half e to the negative t plus 1/2 t minus 1/6. Okay, because everything else is the same. And e to the negative t is exactly the same thing. So it's going to be plus t e to the negative t plus 3/2 of t minus 3/2. Okay, you check to see if you have any like terms, simplify it, and that give you the xp. Okay, and for the first part, e to the negative t, you don't have any like terms, so it's going to be 1/2 of e to the negative t. Okay, the t term, we get the 3/2 of t and the negative half of t. 1.5 and half, that give you just a t. Okay, 1/6. You have the 1/6 and the 3/2 over here. Okay, so this is going to be like 9/6. So that give you, okay, that be what? It's going to be minus, it's minus 8/6. You simplify it, that give you 4/3. Okay, so that give you 4/3. Then the t e to the negative t, you don't have anything for this one. So this would be the first part, okay? It's the same as here, 1/2 of e to the negative t plus t minus 4/3 plus t to the negative t. Okay, and we do the same thing for the bottom one. For the bottom one, again, you don't have anything e to the negative t. It's almost the same thing. It's a negative half. The sign is different on this. Okay, so it's going to be plus. In case of the t's, you get the 1/2 and the negative 3/2 again. Okay, so we get this 1/2 t. When I multiply the second one, it should be all right. Okay, so it's the same one. So that gives you the same thing. It's a 1/2 minus. The sign would be different. It's going to be negative t over here. The number, we have a negative 1/6 and the 3/2. Okay, the same. It's going to be negative 9 and it's going to be negative 10. Negative 10/6 would be negative, okay, 5/3. 5/3 and the rest are going to be the same thing. So that give you t e to the negative. So eventually this would be xp. So the final answer is xc plus xp.
The final for the second line in XP shouldn't be 2t.
Bottom row.
1/2.
Yes, you are right. Very good. is that? Plus 2t. Okay? In fact, I have it over here. Negative 1/2 e to the negative t plus 2t minus 5t plus t to the negative t. Is it correct?
Yes.
Okay. Because this is the one that I'm going to post for you. And you get it right. So it's a nice method. Of course, it takes time, but you can try the direct ones. See, if you try the direct one, you have to memorize a huge number of formulas. The direct one is exactly the same as we did it for the linear equation. It's the u1, u2, the system of equation. In that case, exactly the same one. You are going to have a u1 prime and u2 prime. You have to integrate it. But I used to give that formula and the people memorize it, and they didn't care. But I didn't like it really. Because in fact, you know what's going on with this, okay? And these nicely can be extended, generalized. So it's just 2 by 2. Okay, this operation with the matrices, etc. You can do it with various calculator, etc. But the idea is going to be important for us. Okay, and that's it. The second example would be on the final review. When you get to we have a couple of them on the final review, we check it. Okay, so another one that you have, it's very similar to this one. You see, this is the one I post for you, and we are going to check that one too. So this is how we're going to ask you this question. We give you 2 problems. See the first one and the second one. Second one, as soon as you can even do the second one by the variation of parameter. And of course, undetermined coefficient is much easier because this is linear, t and 1 plus t. But the other one would have something like, exponential one, sometimes the sign, but exponential one would be easy. Just change the underlying system, if you like, of the equation. So make sure you know it. It's 2 problems out of those 2 on the final. Variation of the parameter and the determinant coefficient. Okay, so what I'm going to do, I'm going to remind you that the first part, maybe you need to refresh your memory. That's the 4 questions from the first part that you are going to have, today, to see how far we can go. And then we have, again, we have another class. So we finish it, okay? So what I'm going to do is going to the final review and starting with number 2, 3, the old-fashioned one. 2, 3, 4, 5. They are from the first part of the course. Okay, so number 2 is method of variation of parameter, of course, for solving the linear equation. Number 3 is undetermined coefficients for the linear equation. And number 4 is Euler equation. And number 5, nonlinear system. So that will be your 4 questions from the first part of the course. Other than that, they are all Laplace transform. Okay, so let's, I can give a break if you like, 4:50, 10 minutes. Break, come back. We try to do those 4 today. One of them, okay. So from we are going to do number 2, those classic one first. Number 2, this is solved by method of solve the equation. Okay, by the variation of the parameter. Of the method. Okay, there you are, part 1. One of those famous one. So the equation is y double prime plus y equal to the secant of x tangent of x. Okay, remember we have to solve the homogeneous one first. So we are going to solve y double prime plus y equal to the 0. So characteristic equation is going to be r squared plus 1 equal to the 0. So r squared equal to the -1, we call it I squared. So r would be positive -I. Okay, so we get a complex characteristic. So r equal to the 0 plus I. alpha plus beta I. So your alpha is equal to the 0 and beta is equal to 1. So we are going to introduce the solutions, okay? So the solutions are going to be, we go with the y1, which is e to the alpha x cosine of the beta x. In this case, alpha is 0, okay? So that give e to the 0 cosine of the x, which is cosine of x, the first solution. Okay, then you get the y2, the same thing, e to the alpha x sine of the beta x, which is going to be sine x. So you introduce your yc. So yc would be c1 cosine of x plus c2 sine x. So this is going to be yc. Okay, any question? So yp. Yp method of the variation of parameter. Remember, yp, we are going to reduce yp to be u1. We change these two. It's going to be u1 cosine of the x plus the u2 sine of x, which is the same as u1 y1 plus u2 y2. Okay, and then you have to look for the u1 and the u2. And you have to remember the formula for this. U1 is equal to the integral of, this is 1, we go with the 2. Y2 r of x divided by the Wronskian. Wronskian of y1 and y2. And your u2 is going to be equal to y1 times r of x, the Wronskian of y1 and y2. That's a dx, of course. Okay, you got to be careful when you pick the r of x, make sure that the coefficient of y double prime is 1. So this is it. In this case, the coefficient is 1, so r of x is going to be secant of x tangent of x. You are going to use it for the Euler equation. The coefficient is not 1, and you have to divide by the coefficient of y double prime. You remember. Okay, now we go for the Wronskian. So we take y1 to be cosine x. We need y1 prime, which is a negative sine x. Then you take the y2 to be equal to the sine x. Okay, then you need y2 double prime, which is going to be cosine x. So we're going to find the Wronskian. Okay, Wronskian of the y1 and y2. It's like a cross multiplying. So that gives you cosine of x times the cosine of x minus negative sine x times sine x. So that gives you cosine square of x plus sine square of x, which is equal to 1. The Wronskian is equal to 1. It must be a non-zero number to be able to do it, and it's going to be. So that's going to be your Wronskian. Okay, so we have r of x, u1, u2, and then we are going to form those integral and find it, and then we have. So make sure that you have the u1, u2 formulas, and r of x is going to be when the coefficient of the y double prime is equal. Okay, are you ready? We go to the next part. I'm getting the u1 and the u2. I'm going to form this one. Okay, I'm done. So going here and finding the u1. So this is it. So we go with the u1. Okay, u1, just repeat again, it's going to be negative y2 Wronskian, sorry, r of x over the Wronskian, the dx is going to be equal to y2 is the one that we pick y2 to be sine, so it's going to be negative sine x. Okay, times r of x. R of x is secant tan. So that's going to be secant x, tangent x. And the Wronskian is 1, dx. Okay, that's it. We are going to simplify it to be able to do it because this is going to be equal to the is a negative sine x. Okay, secant is going to be 1 over cosine, and this is, let's simplify, 1 over cosine, and this is going to be sine cosine. Okay, so the thing that we are going to get for this one is going to be this is cosine. So that give you negative sine squared. Just want to make sure I didn't make any mistake. That's a secant tan, okay? You have the secant tan over here, and that was the sine. So, seems to be all right. So it's going to be equal to the what? Is equal to the negative. Yeah, we get negative tangent square, sorry. It's going to be negative sine squared, okay, over cosine squared dx, which is negative tangent squared. Tangent square of x dx. You know that to get the tangent square, you change it to the, take the negative outside, you change it to the secant square minus 1. And then integral of a secant is a negative tangent. And the integral of 1 is just x. So that gives negative tangent x minus, okay, plus x. No constant c because the u1 is a particular solution. So this is going to be your u1. Okay, so secant is going to be around, and make sure you remember integral of a secant, integral of a tangent, and the integral of a secant. Integral of a tangent is ln of a secant, integral of a secant is ln of a secant plus that. Okay, so that's a U1. Any question? Take the U2. So what's going to be U2? U2 is equal to the Y1 times R of X over the Wronskian dx. So it's going to be equal to, we take the Y1 to be cosine of X. Okay, then R of X is secant of X, tangent of X, and the Wronskian of 1. Okay, secant would be 1 over cosine. This would be simplified. It's a cosine x, and that's a 1 over cosine x, and then the tangent. So the cosine and cosine cancel out. That give you integral of a tangent. Make sure you remember, integral of a tangent is ln of the absolute value of a secant, and no constant c. So that gives you your u2. So u2 is ln of absolute value of the secant of x. That's it. That's u1 and u2. You're not done. You have to go back and you form the yp. Okay, remember the yp is y1 u1 plus y2 u2. So it's going to be equal to the y1 was cosine of x, and the u1 is negative tan x plus x plus y2. Y2 is sine x. Okay, it's going to be sine x times z by u2, which is ln of the absolute value of secant of x. There is nothing to simplify for this one. It's going to be as is. So we can declare the solution y equal to the yc plus yp. Okay. But you have to form the yp, and if it's possible, simplify it, remember. You have to form it, and if it's possible, simplify it, and get the final answer. Okay, that's the first one, which is involved is just as you know, this secant sine, the other one that's integral of ln x, x ln x, x squared ln x, those integration by parts that you needed not only for this one, but also for the Euler equation. We have another one, exponential one. Let's do that one too. Just remind you that the integrals that we have to take. Okay, any question? So make sure you have the formula for u1, u2, Wronskian, this type of ideas. So that is part one. Part two, it's a quick one, but it's exponential function. The part two with the same method, we want to answer this one. Y double prime, okay, 1 double prime minus y prime minus 6y equal to the e to the negative x. Again, they ask you to do it by method of variation of the parameter. Okay, let's do it quickly. Homogeneous one first. So homogeneous one would be y double prime minus y prime minus 6y equal to 0. Characteristic equation would be r squared minus r minus 6 equal to 0. Easily factorable, r minus 3 times r plus 2 equal to 0. We have two distinct solutions. The R1 is equal to 3 and R2 is equal to a negative 2. So the corresponding solutions are going to be Y1. Remember, the solution is going to be of form of e to the Rx. So it's going to be e to the 3x. That's going to be your Y1. And the Y2 would be e to the negative 2x. So YC would be C1 e to the 3x plus C2 e to the negative 2x. So that gives you the, okay, general solution of the characteristic equation. That's the one. Okay, any question? Now we want to find the XP method of the variation of the problem. So your XP is going to be XP. Again, is going to be U1, Y1, that's U2, Y2. As we talk about it, U1 is U2. So we have to check the Wronskian again. So Y1 is e to the 3x. Y2 is e to the negative 2x. Y1 prime. Exponential function will be the same. Yes, let's go.
Wait, isn't it, just to clarify, isn't it technically y of p? Because it's not the matrix you want?
But isn't,
You wrote x of p, isn't it like y of p based on previous
oh,
lecture?
sorry. Why? I was just in the mood of the
Yeah,
system of the equation. Okay, YP, yes, thank you. So differentiate that give you 3e to the 3x, okay? And y2 prime would be negative 2e to the negative 2x. Cross multiply to get the Wronskian. Okay, so the Wronskian of the y1 and the y2 is going to be, you get the e to the 3x times it by negative 2e to the negative 2x. Okay, minus the other one, it's going to be e to the negative 2x times 3e to the 3x. Okay, so if you multiply them together, add the exponent. So the first one would be x. The second one would be also e to the x. So that you will negative 5, yes, that's correct. Negative 5 e to the x. Okay, so the Wronskian is negative 5 to the e to the x, which is a non-zero number, and that's good. Of course, it's always non-zero, we know that. Okay, so introduce the R of x. Again, the coefficient of the y double prime is 1, so you don't need to take any extra action. So R of x is going to be simply e to the negative x. So we go for the y1 and the u1 and the u2. Okay, u1 is equal to the negative y2 R of x over the Wronskian. The dx is equal to the y2 is e to the negative 2x. So it's going to be negative e to the negative 2x. The Wronskian is e to the negative x. Sorry, R of x is e to the negative x, and the Wronskian is negative 5 e to the x and the dx. Simplify everything that we have. So on the top is going to be negative e to the negative 3x. And on the bottom, we get negative 5 e to the x and dx. We move the e to the x up. That gives negative e to the negative x, and e to the negative 3x would be e to the So it's going to be integral of -1/5 e to the -4x. -4x dx, okay? Any question? So pull out the -5 and integrate e to the -4x. So this is going to be a -5. Integral of e to the -4x would be e to the -4x, but you have to divide it by u prime. U prime is a -4. Okay, because exponential factor. So the top is e to the -3x. I move this one up. E to the -3x times e to the -x, that give you e to the -4x. Yes, that's good.
Shouldn't it be +1/5 e to the -4x?
Yes, positive. Thank you. Okay, anything else? That's it. Now we have a -4 here, make it into negative again. So it's going to be -1/20. Okay, e to the -4x. We can bring it down or write it down as is, doesn't matter. So this is going to be u1. So the u1 is -1/20 e to the -4x. Keep it because we want to multiply by y1, then maybe simplify. So that's a u1. Any question? Repeat it again to get the u2. Okay, u2 is integral of y1 Wronskian Rx over the Wronskian dx is equal to. So your y1 is e to the +3x, okay? So it's going to be e to the 3x, and the Rx e to the -x, and the Wronskian is -5 e to the x. Okay, that's it, the dx. So the top one would be e to the 2x, because +3x -x. Okay, -5 e to the x. Okay, now this is going to be what? It's going to be -1/5. So it's going to be integral of -1/5 e to the x. Because, you know, e to the 2x, 2x minus x would be just x dx. And then you integrate. Yes, what's the question?
Isn't the top for u1 2 e to the -3x? Is y2 prime is -2 e to the 2 e to the negative.
No, we don't use y2 prime. Use y2.
Oh, right.
The
Oh, yeah,
formula-
yeah.
the formula. Okay, so the last one you integrated, so u2 would be -1/5, okay, -1/5 e to the x. So that would be u2. -1/5 e to the x. Any question? You have to multiply them together, simplify it to get the yp. u1 y1, u2 y2. Probably it would be simplified. Okay, and then, of course, this problem can be done by undetermined coefficient. But, you know, we just want to do it with this, so you remember the formula. Okay, so going and checking the yp. Okay, officially, this is going to be yp. So the yp is equal to the u1 y1 plus u2 y2. Okay, it's equal to the u1 was -1/20. Okay, 20 e to the -4x. Okay, times it by y1. We take the y1 was e to the 3x. Okay, plus u2. U2 is -1/5 e to the x times it by y2. Y2 was e to the -2x. Okay, simplify it. Declare the yp. So the yp would be, that would be -120. We have e to the -4x and e to the 3x, that give e to the -x. Here,
I have 1/20th, not -1/20th.
You had -1.
that's a -120. Because there was a negative inside. Inside of the negative, you see, that's why. outside got the positive 5, but we get e to negative 4x.
Oh,
divided
yeah,
by-
yeah, yeah. Yeah, it's-
Okay, so it's going to be true. So this is going to be minus 1/5 e to the, okay, e to the negative x again. Okay, so that's a negative x. Now we can simplify it a little bit more. So this is like what? This is like a -4, -1 would be -5. So it's going to be -5/20 e to the negative x, which is going to be -1/4 e to the negative x. So this is going to be your yp. Yp is -1/4 e to the negative x. Okay, so the final answer, y equal to the yc plus yp. And then we're done. It's going to be kind of a trigonometric function. It's going to be given to you. So you have a couple of them in your lecture notes. Check it. You should be able to do it. But just make sure to remember those integration involving secant and tangent and x squared and x. Those integration by parts that we do. Okay. And you have the similar one in your previous test. You can check it. So this is one concept. Okay, any question? Variation of the parameter. Now, coefficient and determined coefficient is easy. Let's do this one quickly. Number 3. I'll give you one quick one. So the next concept is going to be, we want to solve it by this method. Okay, number 3. You have to be careful only if it's going to be a repeated solution. It's the only place that you may lose something. Okay, so we want to solve the equation again. This time by using, because we use both methods for the system. That's why we give a question on the equation as well. Okay, using the and determinant coefficient. Okay. Coefficient. Just something like very much like this one. Y double prime minus 5y prime plus 4y equal to the 3e to the x. You know that the choices are restricted, e to the x, sine x, cosine x, or just exponential function. Again, we do the homogeneous one first. Okay, homogeneous one, y double prime minus 5y prime plus 4y equal to 0. Characteristic equation r squared minus 5r plus 4 equal to 0. Factor it. It's a number. It's going to be r minus 4 times r minus 1 equal to 0. So we have two solutions, r1 equal to 4 and r2 equal to 1. Distinct solutions. So the corresponding solutions are going to be y1 equal to the e to the 4x, okay, and the y2 equal to the e to the x. So the linear combination give you yc. c1 e to the 4x plus c2 e to the x. Okay, that's it. That's a yc. Now we bring the r of x and we pick the yp. R of x is equal to the 3e to the x. That's it. So the function is e to the x. The coefficient is a constant polynomial. So we have to create a constant polynomial with the unknown, okay, unknown coefficient. So y of p is going to be something like a1 e to the x, okay? Then you test it. Remember, you shouldn't have any duplication term in the yp and the yc. If it's going to be duplicated, you have to upgrade it. You multiply by x. Then again, you check it. In this case, there is nothing else. And you check it. If it's duplicated again, you multiply by x squared. I think you will a straightforward one. It's just going to be a second order. Okay, so yp is going to be yp is a or a1 x e to the x. So you have to differentiate it and substitute in the original equation and get the a1. Okay, so carefully differentiate it. So prime have to use the product rule. Derivative first times second is going to be a1 e to the x. Second first, same thing because the exponential function is the same. So that give a1x e to the x. That's y prime. Have to find the y double prime. So the first one would be unchanged. Second one, again, you have to use the product rule. Derivative of the first, second, first. Okay, in this case, you can combine these two together. So that give you 2a1. Okay, that give you 2a1 e to the x plus a1x e to the x. Go back, substitute in the equation. These must disappear. You should be able to find the a1. Okay. So in the original equation, that is the y double prime. So it's going to be 2a1 e to the x, okay, plus a1 x e to the x. That's a y double prime minus 5y prime, a1 e to the x plus a1 x e to the x plus 4y, 4a1 x e to the x equal to the 3e to the x. That's it. Simplified, or you can divide by e to the x right away, then simplify, it doesn't matter. Okay, so we have to take the 5 inside here. So that gives us a negative 5a1 e to the x minus 5a1 x e to the x. So these should cancel out. We have 4 negative 5 give you negative 1, and the positive 1 will cancel out. This must always cancel out. Those will be x. So the leftover is going to be 2a1 e to the x from the first one, 5a1 e to the x from the second one, nothing else, equal to 3e to the x. Now we can divide by e to the x because it's a non-zero. So the leftover, 2a1 minus 5a1 is equal to 3. So negative 3a1 equal to 3, a1 would be negative 1. Okay, so your yp is going to be, that's it. So the yp was a1, which is a negative 1, negative x e to the x. That's it. So the final answer, y equal to yc plus yp. Okay, so this will be straightforward, but make sure that if you get a duplicated one, make sure you upgrade it. And because it takes time, we are not going to do anything upper degrees, if you like. Higher degrees. Just a second, just to check the solution. Okay, any question? So that is the second one.
Random question, are we gonna have a extra points number 3?
We asked that earlier. He's gonna take a look at it.
Oh, sorry. That's an error.
Missed that.
We did.
Yeah, I give them the extra 3. Yeah, you have that one. I have to give you a short assignment officially to give you your last 10 points. So just,
10 points?
Yeah, your homework number 4.
Yeah, it was 10 points, right?
Number 4. Okay, I just, give you a couple of problems from that last part that we have. So officially you submitted by the final, then you get your 10 points. Okay, so let's do one more. Okay, that's it. You get time to do the last one is, or the one with the before last, Euler equation. It's the one that you should be, remember it. Okay, number 4. So that gives you 30 points so far. Number 4, we want to solve the Euler equation. Let's solve the Euler equation. Euler equation of this type, the order of the derivative and the powers of the x must be the same. So that's it. X squared, y double prime, you see, a square second, minus 2x, y prime, first prime, and the 2y. The power of x is 0, and the order of the derivative is 0. And this is equal to the x cubed ln x. It's going to be a non-homogeneous one, okay? Because you have to do homogeneous one yourself. Okay, that's it. That's the Euler equation. Again, it's a non-homogeneous one. You have to solve the homogeneous one first, okay? So the solution is going to be, so we are going to take this one, x squared, y double prime, minus 2x y prime, plus 2y equal to 0. Remember, the solution of the Euler equation is of the form of x to the r, not e to the x. So what you're going to do is you are going to get the solution to be like y equal to the x to the r. Then you are going to find the r. This is the way I do it. You don't memorize any formula. So find the y prime, which is going to be r x to the r minus 1, and find the y double prime, which is going to be r times r minus 1 x to the r minus 2. Okay, go back, substitute in this equation, and find the r. You must arrive at the quadratic equation. Okay, we substitute, so this is it. It's going to be x squared, y double prime, it's going to be r minus 1, okay, x to the r minus 2, minus 2x, r x to the r minus 1, okay, plus 2y, which is going to be 2x to the r. It's going to be equal to 0. Okay, you can drop all the x's because if you combine them together, everything would be x to the r. Okay, so this is it. Consider the leftover. So the leftover is going to be r times r minus 1. Okay, minus 2r plus 2 equal to the 0. FOIL it, simplify it. So that gives you r squared minus r minus 2r plus 2 equal to the 0. Combine the like terms, r squared minus 3r. Okay, plus 2 equal to the 0. So nicely done. It's r minus 2 times r minus 1. So we get two solutions. Okay, r1 equal to 2 and r2 equal to 1. So the corresponding solutions are going to be y1 is x squared. Okay, y2 is x, because the solution is going to be of the form of x to the r. But check it for yourself that to make sure that you know that when it's going to be repeated one of the solution is going to be x to the r, the other one is going to be x to the r ln x. So make sure that we are not going to give you complex part. Make sure to remember that repeated part. Okay. So that's it. So we are going to have the YC. So the YC as usual is going to be what? CY1 plus C2Y2, which is a C1 x squared plus C2 x. Okay. Now question is the YP. For the YP, you have to use the method of variation of the problem. All the time. Okay. So we want to find the YP. So the method is going to be variation of the problem. So YP is going to be U1 Y1 plus U2 Y2. And you know that the formula for the U1 U2 as we used it before. And now the one that you must be careful, we may make a mistake is here. Identify the Rx first. You see in the Euler equation, this coefficient must be x squared all the time. So you are not going to have any equation, Euler equation, for which the coefficient of the y prime is, y double prime is 1. So when you pick the R of x, you have to divide whatever you have by x squared. Okay? If you miss it, then you may end up with the integral that would be impossible to find. So make sure that you know it. Yes.
So when you're finding the Rx, like dividing it over, the coefficient of y double prime should always be 1.
The coefficient must be always 1. Yeah.
Okay.
Because in the method of the variation of the probability that you use, you see that coefficient is 1. You have to normalize it. So make sure you do it. Okay. So if your integral getting complicated, probably you miss that part. Okay, so before going to the U1 and U2, take care of this one first. So that's the only case that you got to be careful. Okay, now we go and we form the Wronskian. So start with picking the y1 and the y2. Okay, we already got the y1 equal to the x2, and the y2 equal to the x. Okay, so the y1 prime is going to be 2x, and the y2 prime is equal to 1. Let's multiply to get the Wronskian. Okay, the Wronskian is going to be, that's going to be x squared times 1 minus x times 2x. So that gives us x squared minus 2x squared, which is a negative x squared. X is a positive number because of the ln, so this is not 0 and we are fine. As always, the Wronskian cannot be cannot be 0. Okay, so the Wronskian is negative x squared. Okay, any question? Now we are ready to find the U1 and the U1 and the U2 to get those numbers. Okay, I'm done. So remember your y1 is x squared, and we already got the r of x, x ln x. So we go and find the U1. Okay, I'm done. So getting the U1. So the U1 is integral of negative y2 r of x over the Wronskian, okay, dx is equal to your y2 was x, okay, and we already take care of the r of x, it's x ln x, x ln x, x ln x, and the Wronskian of a negative x squared, x squared dx. You simplify it. So on the top, you arrive at the negative x squared ln x, divided by negative x squared dx. Negative x squared will cancel out. You get integral of ln x dx. You know that you can use integration by parts to find it. Easily, you know, we can find it. You take u to be ln x, and dx to be equal to the dv. You know, your u is going to be, if you know it, you can write it down, we accept it. Okay, if you use cross multiply, then that give you x ln x minus x. So that give you, okay, it's going to be ln x involved, okay, all the time integration by parts, take the u to be ln x and up. Yes, that's good.
Never mind.
Okay, so you may end up with the, you know, x squared ln x, ln x divided by x squared divided by x cubed, etc. So always take the integration by parts and start with the u to go to the ln x. Okay, so that would be u1. Go back and find the u2. Okay, let's find the u2. So the formula for the u2 is the integral of, okay, integral of y1 r of x over the Wronskian and the dx. So your y1 was x squared. Okay, and r of x is x ln x. And this is a negative x squared dx. This time, if you multiply that, give you x cubed ln x. Negative x squared dx. Divide by x squared. It's a negative sign here. Okay, so that would give us what? This is going to be negative x ln x. X ln x. Again, integration by parts. Easy to get this one. Again, you have to take the u to be ln x. Okay, the leftover is going to be dv, is going to be x dx. Then you find the du, which is going to be 1 over x dx. And you find the v, which is going to be x squared over 2. Just integration by part form. That give you x ln x dx is equal to the uv, which is x squared half ln x, minus v du, x squared over 2. Du is 1 over x dx. So this x and x would cancel out. So that give you x squared over 2 ln x minus integral of x half. Integral of x half would be x squared over 4. So that give you x squared over 2 ln x minus x squared over 4. Okay, be prepared for it. All types of hovers times the ln x. Okay, there was a negative sign, so the u2 is going to be equal to the negative x squared half ln x, okay, plus x squared over 4. So this is going to be u2. So the u1 is x ln x minus x, and this is going to be your u2, but you have to form the yp, and if it's possible, simplify it. So we are not done, and you cannot write the yp. Okay, so the yp is u1 y1 plus u2 y2. So your y1 was x squared, and u1 is, so u1 is x ln x minus x times x squared, plus your u2 is a negative x squared half ln x plus x squared over 4 times it by x. Okay, multiply inside. So it distributed that give x cubed ln x minus x cubed. If you multiply this one, that give a negative x cubed over 2 ln x, okay, plus x cubed over 4. So we get to simplify this. This is a 1 and this is a negative half, so the result will be 1/2. So that give 1/2 of the x cubed ln x. And this is a negative 1 and a positive quarter. So that give a negative 3/4, negative 3/4 x cubed. So this is yp. Now you can declare y to be yc plus y. Okay, so you make sure to simplify before writing it right. So just make sure that that part of the integration by parts for the homogeneous part you are okay. So that's it. That's the first part. We have nonlinear system. 2 problems. You know, when the variable x is missing or y is missing, we do it next time. Okay, that's it. I have the solution of most of them that I'm going to review for you. I can post it if you want to have a look, because the second part takes time. Okay, so check it for yourself. You may find a couple of errors, I don't know.